Yesterday we talked about the basics of chemical reactions and just what the symbols look like. So the first thing we're going to talk about today is collision theory, which is basically the idea that in order for two things to react, they have to actually collide into each other. So just because you have a beaker of two different things doesn't mean every molecule is going to react. They have to actually run into each other. And when they do run into each other, there's two parts to it. In order for them to successfully react, they have to have the right orientation, meaning they have to be turned the correct way, and they have to have enough energy. So if they're moving too slowly, when they hit each other, they're just going to bounce off of each other. And if you look at these pictures here, notice that in order for these two molecules to react, this little white one has to collide right at that bond right there in order to make both of these react. So if that happens, then it will actually have a reaction. But if it doesn't, let's say the green one hits the bond, nothing will happen, and they'll just bounce off each other. Or if the green one hits another atom, again they'll bounce off of each other, or if these two hit each other, they would just bounce off of each other. So in order for them to successfully react, they have to collide the correct way and with enough energy. And that's an important concept for this. The next thing is called the law of conservation of mass, or you could have seen law of conservation of matter sometimes. This basically says that we do not have the power to create or destroy anything. So we can't create anything from thin air, and we can't completely destroy something. What we can do is turn things around and change them. So we can turn one form of matter into another form of matter, and we can actually even turn matter into energy using the famous science equation E equals mc squared. But the idea is we cannot create or destroy anything. The reason this is important for this chapter is that every chemical equation has to satisfy this law, which means that the total mass of your reactants, however much you start with, has to end up with the total mass of the products. So what that means is if you start with 2 hydrogen atoms, you have to end with 2 hydrogen atoms. So we call that balancing the reaction. And if you ever get to a question that asks you, why do we balance reactions in chemistry, the answer is based on this law. The law of conservation of mass is the reason why we balance reactions in chemistry. And there's only one rule for balancing reactions, and that is that you can only change the coefficients. We talked about that word yesterday. That's the big number in front. You cannot change the subscripts. So I'll try to walk you through a couple of these, but really you're going to have to come in and see me to have me show you how to balance these reactions, because you have to go back and forth, and I don't have the actual answers on this PowerPoint, so I like to work it out myself with the students. So let me just go through one just to kind of give you an idea in case you're just trying to refresh your memory. For this reaction, notice that we have aluminum over here, and we only have one of them. But on this side, that little subscript tells us that we have 2 aluminums, which means we need to have 2 on the other side as well. So what you're going to do is take a big 2 and put it on this blank right here in front of aluminum. And that means aluminum is balanced. Then you go to the next atom, and for this one we have copper right here. So if you have 1 copper on this side and 1 copper on this side, it's already balanced. And the last thing is sulfate. If you have the polyatomic ion on both sides of the reaction, you can just keep it together as a unit. So we have 1 SO4 on this side, we have 3 SO4s on this side. So in order to balance that, the only place we can put a 3 is right here in front of the copper. You cannot put it in the middle of a compound, you have to put it at the beginning. And that 3 says that we have both 3 coppers and 3 sulfates. So you distribute the 3 to the entire compound. So now sulfate is balanced, but copper is not, because you just messed that up. So now you just have to go back and fix copper and put a 3 here. So your final answer is that you have a 2 in front of the aluminum, you have a 3 in front of the CuSO4, you have a 3 in front of the copper, and you have nothing in front of this last compound, but really what you have is a 1. You don't have to write the 1. You can if you want to, but you don't have to. And that's the whole idea with balancing, is that you just go back and forth. So what you can do is try a few of these on your own, and make sure you come see me to check the answers and have me walk through it if you're not sure what I'm doing here. And here's just a few more balancing examples. The last thing that we did for this lesson was just types of reactions, and there's 5 types of reactions that you're going to be responsible for. The first one is synthesis, and this is where you have 2 or more reactants but only 1 product. So what that means is that you combined 2 things to make one bigger thing. And it could be as simple as taking 2 elements to make 1 compound, or it could be taking 2 little compounds and smushing them together to make 1 big one. The opposite of that is called decomposition. This is when you take one big thing and you break it apart into pieces. So notice that we have AB that broke apart into A separate from B. And again, it could be as simple as taking a compound and breaking it into its elements, or it could be taking a big compound and breaking it into two smaller compounds. The next one is called single replacement, and this is where you have a single element that switches places with an element that's in a compound. So for example, in this first reaction we have BC and we have D all by itself. And notice that D has kicked out letter C, so now C is all by itself and D is now paired up with B. So it's when you have a compound and you have a single thing, and that single thing kicked something out of the compound, so now it's part of the compound and something else is by itself. And the charges really do matter for this. So in the compound you have plus minus. Every time you write a compound, the positive one has to be written first. So in this compound BC, B is the positive one, C is the negative one. If I mix it with a nonmetal, nonmetals are always negative. Notice that you would never switch D with B, because then you would put two negatives together. Since C and D are both negative, they're not going to be attracted to each other. So D is going to kick out C because it's the negative one, and then notice that I still wrote the positive one first over here. If you have a metal, it's going to be different because metals are positive. So in this case, A and B would never stick together because they're both positive. So in this case, A is going to kick out B, and B with partnered up with C, since A is positive and C is negative, and now B is by itself. So the main thing is put your charges on it, and we're actually going to spend a whole day on working on just on single replacement reactions soon. So for now, you just need to be able to recognize that it is a single replacement reaction. The next one is called double replacement, and this is where you have two compounds and everybody switches partners. And don't forget that in a compound the charges have to be plus minus. So if you look at this compound down here, we have A and B together, we have C and D together. And notice that A is positive, B is negative, C is positive, and D is negative. So for double replacement, you have these two compounds, and you're going to switch the partners so that everybody has a new partner, but you still keep it plus minus, plus minus. So A is going to go with the other negative, which is D. So A and D will be together. Make sure you write A first because it's positive. B and C are going to be together, but don't write BC because that's a negative one. It needs to be written as CB. So this is your final answer for this. Notice that I switched the partners, but it's still plus minus and then plus minus. So that's double replacement. And the last one is a special kind of reaction that's actually a fancy word for burning. Anytime you light something on fire, it's called a combustion reaction. And this is where you have some combination of hydrogen and carbon. So this X and the Y, they could be different numbers. For instance, it could be C2H6, it could be CH4, it could be C3H5, so it's just some combination of C and H, sorry. You're always going to mix it with oxygen, you're always going to end up with CO2, and you always end up with water. These three will be the same. Whoops, sorry, let me go back one. These three will always be the same. The only thing that's going to be different is the X and the Y right here. So be careful for this, because if you just look over here, it looks like a single replacement reaction, and if you just look on the right side, it looks like double replacement. So if I ever ask you what kind of reaction is this, you need to first check and see if it could be combustion, and then if you decide it's not combustion, then look at your other four choices and see what you think it could be. Also, just because it has one of these four doesn't mean it's combustion. So every reaction with oxygen doesn't mean that it's combustion. It has to have all four of these things to be combustion. And worksheet 4 in your worksheet packet will allow you to practice this. So if you want to try to label the types of reactions, I can give you those answers. And worksheets 3 and 6 will allow you to practice balancing. Worksheet 6, the bottom half of it is really challenging. So if you feel like you're good at it and you want to try some, I put those on there to challenge the people who tend to catch on quickly for the balancing. But that's optional. So the bottom half of page 6 is optional. And that is all for today.